Hello, I am the Internet Skeptic, and today what we're going to be doing is we're going to be covering the Internet Skeptic's Guide to Global Warming. I've lined them up here so that you can, I mean, it's pretty hard to argue that there's not a pretty tight relationship between those two charts. Okay, well what you have here is on the x-axis, you have latitude. You're going from pole to pole. Over here, you have altitude. So the green level here ends at about 12 kilometers, which is the top of the stratosphere. And up here, the green area stops at about 12 kilometers. And as you can see, as you go to the poles, they taper down. So you're probably wondering, what exactly is that chart that you're showing them? Okay? But if this is atmospheric heat, okay, I just gave it away. This is atmospheric heat, and this is atmospheric water vapor. So here you have the heat profile of the world, and here you have the water vapor profile of the world. They almost overlap.
Now, excuse me, pole to pole?
Yeah.
South pole, North pole, and
yeah.
equator?
This is plus 90, so this is north North Pole. Here's minus 90, this is the South Pole.
Okay, where's New York, for example?
60.
60?
Yeah. You're up here, and actually you can see that it has what's called a fat tail. Temperature has kind of a fat tail, so we're warming a little bit more in the northern hemisphere than we are in the southern hemisphere. So you're in the area where the globe is actually warming a little bit.
From what?
Water vapor.
From water vapor.
Yeah.
From the sun.
Well, we're going to get to that.
You're going to get to that.
The sun plays a part of providing the energy, but we're going to take a look at what would be changing water vapor. Because right now, what's the big focus? The big focus is what's changing atmospheric CO2, people driving SUVs. But that's a trace gas. Why don't we look at what would be possibly changing the major contributor, water vapor. Here's the chart. And once again, Dr. Thompson from Ohio State University uses this chart to demonstrate part of his argument. It totally disproves his argument, but this is what he'll show you. And you show, what do you see here? You see a lot of red up here at the top, and you actually see some blues down here cooling, right? Well, what is this? This is a temperature grid of the world. Right off the bat, you see a lot of red up north. You've got the northern hemisphere warming, correct? Anyone disagree with that? I see blue down here and red up here. That looks to me like northern hemisphere warming. Southern hemisphere, at least, or if not cooling, at least staying the same.
This is his data. Where does he get it?
This comes from Walther et al. 2002 Nature.
What are these? Where is it collected? Is that difficult to do?
I would imagine, well, not really, because you have weather stations all around the world. This is how they're doing it. I mean, this is what you talk about. You talk about these giant super
atmospheric temperature.
Yeah, this is temperature change per decade, and this is basically they've just compiled all the data from all the weather stations.
What's atmospheric?
Atmospheric temperature, yes. From ground measurements, there's a big problem with how they get this data what's called the urban effect. But it does show warming according to their own data. And once again, I don't want to question their data. I'm using their data, so I'm going to give them every point they want. This is warming. They said it's warming. Let's take a look at it. Well, what blew my mind is he's making the argument that CO2 is causing this, and then he provides a chart that shows CO2 is equal in the northern hemisphere to the southern hemisphere. Okay, well, if it's equal, what do you expect to see an equal temperature grid throughout there? But you don't. You see it in the northern hemisphere. Then he throws this in. Precipitation change per decade. And what do you see? The northern hemisphere is getting a lot more precipitation, more water vapors in the northern hemisphere. They, once again, overlap. The drying areas, cooling areas, wetter areas, warming areas. This is their own chart, showing that water vapor, not CO2, is causing it. That's their labeling, not mine. Precipitation, temperature. And here you have it. Now it gets to the crux of it. So you're saying, well then what exactly is causing this big problem? Ironically, trees are causing the global warming. Because what causes the majority of water vapor? Trees do. Through evaporation and through something called transpiration. Evaporation's off the oceans, and with all this new vegetation, most people don't realize that we've had a greening of the northern hemisphere. People will say, well, but they've been cutting down trees. Well, they've been cutting down some trees, and the acreage may have decreased, but the density of these forests have become much more dense. So you have more trees per acre producing more CO2. Ironically, but once again, you can see that we're clearly much greener in the northern hemisphere.
Can you demonstrate what you just said?
With only with their
more
chart.
trees and
Oh,
more-
that's what this chart shows.
That's what the chart shows?
And I do have something else coming up also
Okay.
that addresses that. I love these questions though.
Yeah. I'm
Because
letting it roll for 58 minutes.
are we near 58?
No, no.
Okay.
We're 35 into
Okay. Well, you can see that we've had basically a substantial greening in the northern hemisphere, which is producing a lot more water vapor, which is trapping a lot more heat. The unfortunate thing about this, and this is why it is so important to understand the science, because if you don't understand the science, you can't solve the problem. Okay? In healthcare, if you don't have the right diagnosis, you can't cure the patient. If you're going to go around blaming CO2 for everything, it's like a patient comes into you with a headache due to a brain tumor and you just keep giving them an aspirin. You'll never solve the problem. So if you misdiagnose it, you can never solve the problem. What is Al Gore's solution to fighting global warming? He wants to cut CO2 by doing what? Planting trees, basically contributing to the water vapor in the atmosphere. I would argue that he's actually going to make the matters worse, not better off. Now, let's go and take a look.
Oh my God, you're like against trees. This is going to shake.
No, I'm not. Well, I'm not against trees. I am very much for trees. And I'm going to get to that also.
Okay.
I'm definitely not against trees.
This was in the Dayton paper this morning.
What was?
The trees create more problems.
Oh, really?
Yeah.
I'm actually going to get to that because remember what I said was, have we done something to tamper with Mother Nature?
Right.
And we have. And I'm going to get to that. I'm going to show that that's the problem, not the trees. We need trees. Also, by the way, just flip back. CO2, by the way, is plant food. CO2 is atmospheric fertilizer. Trees die without CO2. I'm right now breathing CO2. Mother Nature. Organic chemistry is the study of carbon. We are carbon-based life forms. So to argue that CO2 is a pollution, I think, is a real stretch. The other thing is, this is another thing that really should catch your eyes. When you're going to go out there and you're going to create a model, you're going to want to understand all the variables that could go into this model. Now, this comes from the IPCC report. Right? This is the International Panel of Climate Change report. This is the top scientists in the world. Now, before I cover it, I want to just review common sense on how you run a scientific experiment and the scientific method. Let's say I was going to do a study on weight loss. If I was going to do a study on weight loss, I would have to have data on caloric intake and exercise. Those are the two factors that are most likely going to explain the majority of my weight loss. If I did a study on weight loss and didn't include those two variables, I can create a model, but it's not going to be very significant. It's not going to explain it very well, right? Now, it may correlate well, but correlation doesn't prove anything. Like, I could find some things that could correlate, but it wouldn't mean anything unless you had the major factors that worked within a theory. Exercise, caloric intake leads to weight loss or weight gain. So if you're thinking about global warming, you got to think about what are the major factors you'd want to have in the model. Well, right off the bat, I would think that most people would, they walk out on their porch, the sun comes down and warms it up, and think, you know what, I bet the sun probably has a little something to do with this global warming stuff. So I want to make sure I understood it pretty well. I pretty much showed you that water vapor causes or traps most of the heat. So I would expect the IPCC, the major bodies who speaks on this, to clearly understand or clearly have defined the sun and water vapor. Well, here's the chart that they produced, and down here at the very bottom.
Excuse me, IPCC is?
Yeah, IPCC, the International Panel of Climate Change. This is the UN's report. This is what everyone's talking about.
Why don't you show, you're covering the UN little insignia.
Right.
Okay, let me zoom in on that. Okay, thank you.
Right.
So in other words, this is their data.
This is their data.
Okay.
Yeah. But going back to that theory, the example of a model, you'd expect the IPCC to know a lot about the sun, know a lot about water vapor, because you would think those would be the most significant factors in the model. Well, here you have a chart that shows Level of scientific understanding. Very high to very low. What do they know a great deal about? CO2. What do they know the least about? The dead last one. Solar. So we've got a scientific consensus when the scientists come right out and tell you that they don't know a heck of a lot about one of the most significant variables. That's like me saying I know a lot about weight loss, but I don't know anything about exercise or diet. Does that even make any sense? So how can you reach a scientific consensus when even the scientists admit we don't know anything about the sun? I showed you the chart that there's quite a bit of data out there. I would argue that they're probably just ignoring it. The other thing is, what's the one that I pointed out is probably most significant? Water vapor. Can you find water vapor on this chart anywhere? They don't even bother to mention it. The closest you can come to it is this little bag of aerosol plus clouds. Okay? You could probably say clouds works as water vapor. But you'd expect them to have water vapor here. They label CO2, methane, nitrous oxide, and halocarbons, greenhouse gases. Of course, they don't mention water vapor as a greenhouse gas. But I can't find water vapor anywhere. So the two most significant factors of global warming, they either know little or nothing about. And yet there's a scientific consensus.
It's not used in the data. It's not that they don't know about it. Because scientists must have been measuring sun and water vapor.
What I'm saying is,
Not
according to
these
their,
scientists.
yeah, I'm just well, this is the IPCC.
I see.
I'm saying according to the authoritative body, this is their data. They're the ones saying it's not.
But now explain this level of understanding again. What does that mean?
This is the level of scientific understanding. This is when they polled the scientists, they said, what do we know a lot about? We know a lot about CO2, which goes right into that theory about Margaret Thatcher. They were paid to go search for CO2. So they totally ignored the major factors. The bottom line is, you can go out there and find correlations between anything. I could go do a study that shows that, if I did a study on stork populations in Europe and birth rates, what I'd do is I'd find that over time, the stork population has fallen. Over time, the birth rate has fallen. So I can create a model that says the falling stork population has caused the birth rate in Europe to fall. That doesn't make any sense, but I can find correlations. So what they've done is they've gone out and find all these what are called spurless correlations, CO2 going along with things, and it doesn't even go along with temperature very well. But they've gone out searching for data to prove CO2 does it without really looking at the big picture.
I'm just, excuse me for being a little slow.
Sure.
It's just, it looks green on high and red on low, this level. Now, are these colors?
Yeah, this is the spectrum, and this is very
You
low.
mean they charted out from high to
Yeah.
What do they know about?
This is high understanding, and this is low understanding.
And there's no water vapor at all.
There's no water vapor.
At all.
And it also says they don't know anything about the sun.
The sun.
But at least they put it in there.
They did,
You
yes,
guys
yeah.
handed to them for
Yeah,
putting it
they
in
did
there.
put it in there.
Okay.
And land use, they don't even know what the hell.
But this is a qualitative chart.
It's qualitative.
So why did they bother to make one bigger than the other?
That's a good point. That's a very good point. I don't know.
To fill the page.
Yeah. But I just find that I cannot believe that they go out there and tell everybody that there's scientific consensus, and then they point out that they don't know much about the sun. To me, just running a scientific experiment, that just doesn't pass the stink test.
What we're missing here is an energy balance and a mass balance.
That's in a coming presentation. I don't have that data here, but I do have that.
That would tell you a lot.
It ties it right to the solar output. The solar output, there's two things. The solar output can explain almost 100% of the global warming temperature, the temperature increase, just due to the sun. That report is coming out, and I have
And
it.
then an energy balance.
It's an energy balance argument. And you can argue that the CO2 increase is due to the increase in the ocean temperature, not driving SUVs. So I do have it there. This is once again, and I'm using this one to show you how they go out and they make these arguments. And the damage I see about global warming theory is that their arguments are so plausible. When you hear them, no one doubts them. And then they throw in polar bears to get the emotional argument for it. Okay? But I like to just look at the facts. Well, this is Lonnie Thompson, by the way. And I think this is actually shown in Inconvenient Truth. This is Lonnie Thompson, and when you watch him, he tells you about these melting these glaciers, right? Would anyone disagree with me that he's telling you that the glaciers are disappearing implying at least that they're melting due to global warming. Would anyone disagree with that?
No. He says that.
That's what he says. Well, look very closely. This is Lonnie Thompson next to a disappearing glacier. Do you notice anything odd about that? Now, you claim it's melting due to heat, where global warming is causing these glaciers.
Oh, I see. It looks like it's been chiseled off or dropped.
This is a desert. There's not a drop of water around here. He's not standing in mud. He's standing on bone-dry desert. What's this making these glaciers disappear isn't that they're melting. They're evaporating.
Subliming.
Sublime, yeah, exactly. Matter of fact, if you watch Planet Earth, if you watch the Planet Earth series,
Yeah.
okay, this is something you're going to definitely want to do because it makes a lot of my cases. They covered the Gobi Desert in this thing. And they point out that the Gobi Desert gets a huge layer of snow. And they point out that in the Gobi Desert, which is I believe the second largest desert, when it snows, it never melts. They show the desert, then they show snow layer, then the desert again. And they explain how the snow evaporates, it doesn't melt. And sure enough, if you use, once again, Dr. Thompson's own data.
Oh, wait a minute. That's sublime is from solid
Gas.
to gas. Evaporate is from liquid to gas. So you
Oh yes, you're okay. You're right.
You should use
Sublime. You're absolutely right. This is sublimation.
Final point.
That's good because I do say evaporate. I use it just because people understand evaporate. They don't understand sublimation.
But your point is, I never thought of that. Your point is very good.
Yeah. Well, it's the same process of freeze drying. It's exactly how you freeze dry things.
Absolutely.
Okay. More importantly, Dr. Thompson will show you, and the big one is his Kilimanjaro one. He'll sit there and he'll talk about Kilimanjaro. Then he shows you this chart. Well, sure enough, his own chart shows you Kilimanjaro is in an area of global cooling. Right? It also happens to be in an area of drying. So you've got a cooling, drying area eliminating this glacier, not warming and melting. Once again, it's their own data.
That's quite an amazing point.
Yeah, well, we were working on it. This is the other one.
But to sublime, you have to have the conditions for sublimation.
What are the conditions for sublimation?
Vapor pressure in the air has got to be less than the vapor pressure at the surface of the ice.
And that gets right back to the water vapor. Only problem is there's the opposite, right? The water vapor in the atmosphere has to have been decreased, right?
Right.
And that's what's going on.
Sublimation to occur, you have to have dry air.
And that's what's happening. The drying's going on. And so they've got dry air going. They don't have the precipitation. Once again, it's the southern hemisphere. They don't have the precipitation impact that we have up in the north. And I've got data on that. The other one is they show the big one. Let me see if I've got the chart next. The other thing is they always show Antarctica and they show the Larsen B shelf. They show the Larsen B shelf breaking off. And Al Gore, when you watch him, he makes it very clear in his movie that scientists told me if you see that Larsen B shelf break off, we're in a lot of trouble. First of all, and I get to refer back to this popular show now, Planet Earth, watch the one on the poles. It tells you that during the wintertime, Antarctica doubles in size. It goes from this to this because the ice expands. So Antarctica is very used to, on an annual basis, expanding a great deal and then shrinking back down. So seeing an ice shelf break off should be no surprise. More importantly, didn't anyone bother to think about if he's claiming it's due to global warming, someone look at the temperature in the South Pole? The temperature in the South Pole, you're talking minus 20 degrees at the warmest throughout the annual cycle. Okay? Antarctica is very cold, so it's hard to argue that global warming in an area where the temperatures are minus 30 degrees is causing these ice caps to break off.
Okay? Wait a minute now. Expansion. The continent expands, did you say?
The continent expands, doubles in size during the winter.
Now, ice is roughly, 90% of the density of liquid water. What would make it expand?
It's the wintertime, cool.
Snow.
Turns ice. The oceans freeze.
You're creating ice.
The oceans freeze.
The oceans freeze. Yeah, the oceans freeze. And then they contract again.
I don't know where that.
Yeah. Once again, it's
we're doing, but Antarctica is mostly land, so you're saying the ocean around this continent
Freezes. Yeah. Matter of fact, have you seen the movie March of the Penguins? They covered it. They have to get to the shore before it freezes, or they'll starve. Okay. It's a fantastic statistic, and once again, I have the data on it from the Polar Research Center that states that it doubles. But also, they do cover it in Planet Earth, the polar region, and they talk about it. But once again, the whole theory is if it expands by twice and then contracts, what's the big deal about seeing an ice shelf break off when they go through this warming and cooling on an annual basis? More importantly is how in the world could be due to global warming if you never get above freezing? You never even get close to freezing. This is minus 30 degrees.
I thought it went up to like 30 plus degrees in the summertime.
In the North Pole, maybe the North Pole.
No, in the South Pole, I thought that it went up.
Well, we're gonna actually. I could get to that. I have a slide on it that explains that. That's in another presentation, but I do have that, and I can talk to you about it a little bit later. Or I can try to find the
No, go ahead.
But actually, that's a great control to demonstrate, once again, water vapor versus CO2. Because down in the South Pole, and you're right, on the coastal area, it does warm. Because what's warming that isn't the atmosphere, it's the water vapor. I mean, the water. The water comes down there and melts it. More importantly is, on the coast, you have a lot of water vapor in the atmosphere. You're essentially down at the same latitude, but you've got a lot of water vapor. The coasts are very warm. As the air goes across Antarctica, what happens? It precipitates out. So when you get to the center of Antarctica, there's no water vapor in it. Well, guess what happens where the world's coldest place is? Consistently, the South Pole, because there's no water vapor there to trap the heat. So you have a great control, and you always talk about scientific controls. You have essentially the same land area, but on the coastal area where there's water vapor, it's very warm. As you lose water vapor, the temperature plummets, and you're still getting relatively the same sun, relatively the same part of the world.
Except for the big ozone hole.
There's an ozone hole. We got that covered in those.
10 minutes.
10 minutes, okay. This one I just want to show through in because of what I would argue is, once again, the dangers of not understanding the science. This was back in '74. Now, back in '74 is when I was a kid. I didn't have the fear of global warming. I had the fear of global cooling. And they had a full-out blitz. I remember watching that show In Search Of, the coming ice age. We had that oil crisis. And when I was growing up, I was in a lot of fear that I was going to freeze to death in a few years. Okay? This is basically just a report. It was called Cooling World. It comes from Newsweek. Okay? And once again, you can download this, click it. Just recently, Newsweek went back to kind of backtrack and said, remember global cooling. They went back and reviewed the science of what they said. Okay? So within my short lifetime, not as short as it used to be, but I like to still think it was short. Within my short lifetime, they've gone from one end of the spectrum to the other one. They've gone from a global cooling or an ice age to now it's global warming. I've never seen any kind of real science go from have a consensus change that rapidly. Okay, but they've done it in global warming. I mean, literally going from one end of the spectrum to the other. And the last time I think you could make that argument was 1492 with the flat Earth. Someone finally sailed around. The consensus changed overnight.
What do you get wolf up there in the corner?
The crying wolf. They're back here. Never cry wolf.
Oh, I see.
Remember,
and Wolf Blitzer, has he had any involvement?
He just reminds me to say, watch out for the crying of wolf, because they were crying this back when I was a kid also. So I had the Never Cry Wolves there. I do this for entertainment for the kids. So these are just ways for me to keep them entertained.
So Wolf is
well, I don't know what Wolf's opinion is on this, and Wolf, if you see this, I apologize. However, anybody over at CNN want to talk to me, get a hold of me. That's Wolf Blitzer.
Okay.
Wolf Blitzer. There it is, melting of the ice caps. Okay, now this is what was so damaging about this theory. From that report, now remember back in '75, they were worried about global cooling. Today, we're arguing about, my gosh, the polar ice caps are melting. Well, back then, what were they recommending? Read it yourself. They proposed such as melting the polar ice caps by covering it with black soot. Now imagine what would have happened today had we listened to the climatologists back then. We would have melted the polar ice caps, and we would have flooded Manhattan like Al Gore shows. But once again, had we used their data, we would be 6 feet underwater right now, according to their own stuff. Okay? So here is, once again, I get back to, here's the real culprit. Fire prevention. What we've done is we've implemented a policy of fire prevention in our forests that has allowed our forests to become unhealthy overly dense in an unhealthy manner. That's why we have catastrophic forest fires where we didn't have them back in the past. Mother Nature did a good job thinning them out. She'd burn them. Okay? So when you ask, what has man done to really change it? Well, man's changed Mother Nature a lot. He's implemented a fire prevention force. And here you have the Bitterroot. This is just an example. Bitterroot 1895, 1980, and 2001. Our forests have become too dense, and they're actually unhealthy, so they're dying, or they burn down very easily. And you can imagine when they talk about Yellowstone, when it burns down, 6 million acres burned, that's a lot of CO2 being pumped up there that's been trapped for 100 years. More importantly is, you got a lot of plants pulling water out of the ground. You're drying, you're creating an arid environment to begin with, and that's possibly what's going on over in Kilimanjaro.
Let's slow down over this. The first one is a healthy forest in 1895.
That's without man's intervention.
Without man,
Yeah.
a couple, log cabins. The second one is what,
1980.
1980.
100 years later.
And we see a very thick, dense forest and like a lodge, okay?
That is dying.
And now it's dying.
Basically, we've overcrowded the forests. We've taken a nice little rural area and we made this Manhattan. Our forests have become Manhattan, whereas they used to be a nice little rural community. Over here, it actually reviews the numbers. Many ponderosa pines are 15 times more dense than they were a century ago. Now, if you have 15 times more trees producing atmospheric water vapor, don't you think you'd have a lot more water vapor? I mean, rainforests literally create their own climate. They put the air up there, then it comes back down in the rain.
So you're not saying trees are bad, you're
No.
just saying there's an unhealthy balance.
I'm saying that man has interfered with nature and created an unhealthy balance. We've created too many water vapor producing trees.
Is this from the Forestry Service?
I believe it's from the Forest Service.
It's not yours.
No, none of this is my original research. Okay. Once again, where there were 25 to 30 trees once grew per acre, there are now 500. And I'm not arguing against trees. We need trees. They produce a lot of CO2, but they also create water vapor. And the main point is that planting trees wouldn't be the argument to solving global warming. It actually would probably contribute to it. So my argument more is that man has tampered with Mother Nature. But Mother Nature invented lightning for a reason. If you watch Planet Earth, you see how Mother Nature uses lightning to make sure that the natural cycle is maintained. Man's gotten in and tampered with it, and we've created a situation where we've made our forests overly dense. Now, instead of having these healthy little fires that would thin things out, now we have what they describe as catastrophic forest fires. Okay, and I don't think that's healthy for man or for Mother Nature.
2 minutes.
That's about what I've got.
Yeah.
Let me see what else I have here. This basically just shows CO2, how insignificant CO2 is in the big picture thing. This is the atmosphere, this is nitrogen, this is oxygen, this little sliver here is CO2, and man only produces 5% of that 3.5. So if you're really going to point at CO2, there's really not a whole heck of a lot of stuff there. Oh, the other thing, let me say one last thing. As far as the CO2 absorption, it only really absorbs at 3 very small bands. The atmosphere is already saturated with enough CO2 that 100% of the IR at that wavelength is absorbed by 10 meters. So you can't absorb more than 100%. So by increasing more CO2,